Welcome to 3.5, Solving Systems of Linear Inequalities. Okay, this should go relatively quick. I want to show you a couple problems and then let you go to work on your own. Let's go to work. Okay, let's start with these two example problems. And in both of these, they're given to us in slope-intercept form. Just as a reminder, slope-intercept form is y equals mx plus b. So looking at number 23, my y-intercept is -3, and put a point there on the y-axis. I can see that my slope is 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And it has a line underneath, so that tells me it's going to be a solid line. And I finish by putting my point on the y-axis and reading the sign, and this sign says less than, so I would shade below that particular line. Doing my other line in red, I can see that my y-intercept is 2. My slope is a -4, so I'm going to go down 4, 1, 2, 3, 4, and over 1. And it's going to be a dotted line. And I finish by putting my point on the y-intercept and read the sign that says greater than, so I would shade above that line. And now I'm looking for my double shaded area, which is right here. Now that's the only way to do a system of equations, is by graphing both of them and looking for our double shaded area. We move on to number 24. Again, I'm just graphing both lines. The first line, let me go back to blue. My y-intercept is 2. My slope is a -5/3, so down 5, 1, 2, 3, 4, 5, and over 3, or to the right 3. My line is going to be solid because it's or equal to. And I'm going to shade below the line because it is less than. Okay. My second line, which I'll do in red, is a special line. That's y equals a -3. And that's a horizontal line, and it's going to be dotted because it's not or equal to. And that is greater than, so I would shade above that line. Okay, so again, I'm looking for the double shaded area. And that would be right in there. So you can see if it's in slope-intercept form, it's really relatively easy to do. But what if that's not the case? What if it's given to us in slope-intercept form like this next one? Now, we've done this already. We could manipulate both of these equations until they are in slope-intercept form and solve for the y, or we could use Desmos. That's right, our handy-dandy graphing calculator. Notice that I've already put both of these equations, x minus 2y is greater than or equal to -2. That was our red line here, which is solid and shaded below. And then 3x minus 2y is greater than 2 is my blue dotted line, and again shaded below. So I can see quickly my shaded or double shaded area. And yes, this is totally legal and acceptable to do. So let's look at another problem just for fun, okay? One that's not in here. So let me get rid of these two and simply type it in as easily as you read it. 2x plus y, and then I'll use the, sorry about that, hid the operations for me, and that's greater than -1. There's my first, see how it graphs it for me immediately. And then x plus 2y is less than or equal to 4. And boom, I could then draw that on my, so I got -2, 3. That's my point of intersection. I got 0, 2, and 0, -1. So this was a dotted line here. This is a solid line there. And this is my double shaded area. Pretty simple, huh? All right, that's the last section, 3-5. Y'all have a great day.